Welcome to Current and Resistance. This is a special topic because up until now, we've just dealt with one charge moving at a time, or maybe two charges moving at a time. But this topic, we're going to be discussing millions of charges moving at a time. And this distinction is very, very important because one charge moving at a time does not give us all the comforts of the modern world. It doesn't light our cities. What lights our cities are millions, billions, trillions of charges moving at a time, and that billions of charges moving is called current. All right, and that is what we're going to start to explore this week. What is current? How do we govern how big it is? How do we control it? How does it add? How does it subtract? And I'm excited to get into it. Let's start with the quote of the week, which is given by Marianne Williamson, who was actually a candidate for president this last round. Didn't make it too far, but I thought it was cool that kind of a spiritually minded person was actually running for political office. And she says that each of us has a unique part to play in the healing of the world. And I love this because I don't even know if there's anything to explain there. Each of us have a certain set of gifts. And I think that it fills us up. It makes us feel fulfilled when we're able to use those gifts to heal the world, to help others, to contribute. And so I think the journey of a lifetime, the quest of a lifetime, is to find out what is that little unique gift that you have and how can you manifest it in the world so that you leave the world a little bit better than when you came here. That's all. Why do we care? We're going to dive a little bit deeper into the electric power of the electric eel, which is a creature that happened to harness this power of electricity and current to be able to defend itself. How awesome is that? So we're gonna look at that. And so with that said, I want to look at current for the first time. And so if you could go to the slide that says current, the blood of the electrical world, right? Just like our veins have this blood that pumps to all the different parts of our body that give it life. You can kind of think of current as moving through the conductors, the veins of the electrical world, and bringing our electrical world to life, right? Bringing our cities to life, bringing our computers to life, bringing our rooms to life with lights. So I just want to read this really quick. Current is the flow of charge from one region to another. It is electrons doing the flowing through the conductor or wire. It's not positively charged particles. It is electrons. So why is that? Again, you have these protons that are bound to nucleus. If the protons were the ones moving, the actual substance that the conductor was made of would constantly be changing because every time it lost a proton, it'd be a different material. Imagine what a chaotic world that would be if suddenly your copper wire turned into magnesium, and that turned into carbon, and then that turned into on and on and on. Hydrogen, suddenly it's a gas, right? No, that can't happen. But you have these electrons in conductors that are loosely bound to their valence shells, and if you add a little bit of energy, like a potential difference, then those charges get to flow. Pretty cool. And so they don't flow at the speed of the electric field, right? The electric fields actually can travel at the speed of light, but they flow with something called the drift velocity because really, as you can see from this picture, electrons are just, they're riding through there, but there's impurities and there's things to knock into, so they're just like, oh no, oh, geez, oh, my God, right? And so they don't get to move as fast as the electric field. They have something called the drift velocity, which is on the order of a few meters per second, all right? And one important thing to note early on is that the units of current are called amperes. All right, just an A symbol. Okay. Now the direction of current is something I need to clarify right away because it's a little bit awkward. Benjamin Franklin was a great fellow, very, very smart guy. Most people don't even appreciate how unbelievably ingenious this man was. They just think of, founding father. No, he was a scientist. He had this crazy idea of creating the first submarine. In fact, while on his clock, the first submarine was actually created, and he thought of using light as the bioluminescence. You guys have probably heard of bioluminescence, where you activate certain small one-celled particles inside water, and they actually light up. And so Benjamin Franklin wanted to use bioluminescence to actually light the way for submarines to go between the harbors during the Revolutionary War. Pretty cool. And all the other things that he's done, he made one big mistake because he didn't know what actually moved. He didn't know that it was the electrons that moved. So Benjamin Franklin, if this is the positive side of the battery and this is the negative, right, and I have over here a resistor, all right, Benjamin Franklin said that through a circuit, the electron leaves the positive end, so the plus end, right, and it goes towards the minus end, right? He was wrong. So because we know that it's electrons moving, current actually flows from the negative side of a battery, the negative terminal of the battery, to the positive terminal of the battery. But because all of physics has been built on this mistake, we kind of just keep going with it. For now on, I am always going to pretend as though current leaves the positive terminal of a battery, when really, in fact, we know in our heads that it's electrons flowing from the negative terminal.